Now we go straight to the next one, and that's year 2002. There was no question on circle geometry in paper 2 in year 2001. Now, in 2002, it was question 4B. Question 4B. And what's the question? This is the diagram. And the question is, in the diagram, O is the center of the circle. The side AB is produced to E. Side AB, as we can see, is produced to E. Angle ACB is equal to 49 degrees, and angle CBE is equal to 68 degrees. Calculate Roman figure 1, the interior angle AOC, and Roman figure 2, the interior angle, Roman figure 2, angle BOC. Now, first of all, we want to find the interior angle AOC, which is this angle. We want to find this angle. How do we find that angle? We know that angle ABC is equal to 180 minus 68 degrees. Sum of angles on a straight line. Angle ABC plus 68 degrees equals 180. So angle ABC is equal to 180 minus 68, and that's the same as 112 degrees. 180 minus 68 is 112 degrees. Now, if we know angle ABC is 112 degrees, that simply means reflex angle AOC, which is this, is going to be 2 times ABC. Reflex, I can now say reflex ABC, reflex angle AOC rather, reflex angle AOC equals 2 times angle ABC. And the reason for that is angle at center equals twice angle at circumference, and that's 2 times 112, which is 224 degrees. You should take note of the angle. You can see that the angle at the circumference is facing down, so the angle at the center, that is going to be twice the angle at circumference, will also face down. So reflex angle AOC is equal to 2 times angle ABC. Now that we know reflex angle AOC, we can find interior angle AOC. So I can now say interior, therefore interior angle, let me just write INT, interior angle AOC is equal to 360 minus 224. And the reason for that is angle at a point. Some angles at the point is 360 degrees, and that simply means what's 360 minus 224, and that's 136 degrees. So the interior angle AOC is 136 degrees. Now, what is Roman figure 2? That was Roman figure 1. 4B Roman figure 1. And now to Roman figure 2. What does that say? Roman figure 2, find angle BOC. How do we find angle BOC? I think we can do that by completing this diagram. Or let me even break it down. How do we find angle BOC? That's also a piece of cake. How do we find angle BOC? Let's bring a diagram down here. This is a diagram. We want to find angle BOC. Okay, let me do this. Let me join O to B. Now, how do we find angle BOC? First of all, I know that, okay, if I know ACB, angle ACB is 49 degrees. What else do I do? Now I know the whole of angle AOC. I know the interior angle AOC. The interior angle AOC, which is this angle, is 136 degrees. Yeah, that's correct. So that means angle OAC is equal to angle OCA. And the reason for that is base angles of isosceles triangle AOC. OA is a radius, OC is also a radius. That simply means triangle AOC is an isosceles triangle, and its base angles, which are OAC and OCA, are going to be equal. So angle OAC equals angle OCA, base angles of isosceles triangle. Let me write that base angles, that's a reason, of isosceles triangle, our isosceles triangle AOC. Now when angles are the same, you can use the same algebraic term to represent them, so that it will be easy for you to find them. Let angle OAC, which is equal to angle OCA, be equal to x. So that means x in triangle AOC, x plus 136 degrees equals 180 degrees. Angles in a triangle, this is x, this is also x, and this is 136. So that means x plus 136 equals 180 degrees. And that simply means 2x equals 180 minus 136, which means 2x equals 180 minus 136 is simply that's 44 degrees. I hope that's correct. Yeah, 130 plus 40 is 170, plus 4, 174, plus 6, 180. Yeah, that's correct. So that means x equals 44 over 2, which is 22 degrees. That angle OAC. So that means angle OAC, therefore angle OAC, which is equal to angle OCA, is equal to 22 degrees. And what that simply means is that this angle OCA, is 22 degrees. Angle OCA is 22 degrees. And now I can bring out the whole of triangle BOC. Let me bring out the whole of triangle BOC. This is triangle BOC. So what triangle BOC looks like? This is triangle BOC. This is BOC. Now I know the whole of angle OCB. Angle OCB is the whole of this, and that's 49 plus 22. Angle OCB is 49 plus 22. So the whole of this is 49 plus 22, which is 71 degrees. You have to be sure. 49 plus 22, that's 71 degrees. The whole of angle BOC is 71 degrees. And I know, okay, if the whole of angle BOC is 71 degrees, yes. What do we now see? We can see that triangle BOC is also an isosceles triangle, because OB is a radius and OC is also a radius. So triangle BOC is an isosceles triangle. So I can say angle BOC, or let me say OBC, is the same as angle OCB. What's the reason for that? Base angle. Let me even write this first of all. OB, length OB is equal to length OC. And what's the reason? They are both radii. That's the reason. If you check the circle, in the circle, length OB is the same as length OC. They are both radii. Length, distance from center to circumference. So that means this length is equal to this length. So we can now say triangle OBC. Angle OBC equals angle OCB. And the reason for that is base angles. Angle OBC equals angle OCB, which is 71 degrees. And the reason for that is base angles of isosceles triangle OBC. Let me call it OBC. Base angles of isosceles triangle OBC. So if I know that, that means this is also 71 degrees. And I can now find BOC. So BOC plus 71 plus 71, angle BOC plus 71 plus 71 equals 180 degrees. Sum of angles in a triangle, and that means angle BOC equals 180 minus 71 plus 71 is 142, and that simply means 180 minus 142, which is 38 degrees. So angle BOC is therefore equal to 38 degrees. And that's it. Very, very simply. If you're able to remember the theorems, you are never going to miss any question on circle geometry. All right, thank you very much, and I'll catch you in the next. Bye bye.